Ladies and gentlemen, let's discuss about production, transfer, and cryopreservation of buffalo embryos through multiple ovulation and embryo transfer technology in Sri Lanka. In Sri Lanka, we have 0.32 million buffaloes presently. Out of that, 0.28 million are categorized as local, or they are processed with the Niliravi, Mura, or Surti buffaloes. However, when you look at the available data, our present buffalo population is stands still over the last few decades. Under that circumstance, multiple ovulation and embryo transfer technology can be utilized for the rapid multiplication of existing buffalo population using genetically superior animals. For an example, when you use a single buffalo for the natural mating, those animals may provide around 8 or 10 buffalo calves within its lifespan. But when you use the same animal for the multiple ovulation and embryo transfer technology, we can collect around 200 embryos from that particular animal within its lifespan. So not only that, when you talk about the embryo freezing, it would be very much supportive for the planned breeding programs. So not only that, it would be very much supportive for the transportation of live embryos from place to place without any damage. However, there are no report about the multiple ovulation and embryo transfer technology for buffaloes in Sri Lanka. These are the objectives in our study to validate multiple ovulation and embryo transfer for buffaloes in Sri Lanka, to establish a buffalo embryo bank in the country. With that objectives, these are the two first parity Mura buffaloes we have used as embryo donors at the superovulatory program. Then at the superovulation, we used PGF2 alpha at the day 1 and day 16 of the program. Then we inserted controlled intravaginal progesterone releasing devices at the day 7, and we removed those at the day 16. Then FSH is the main hormone we have used as the superovulatory hormone there from the day 14 of the program for 4 consecutive days with reducing doses in both morning and evening. Then at the day 18, we could observe the signs of estrus. As you can see here, as you can see in this picture, we could observe thick, colorless, ropey mucus hanging from the vulva and vulval swelling like that. So with that signs of estrus, we have given GnRH injection intramuscularly. Then in the same day, we have done 2 AIs, morning and evening. The following day, or the day 19th, we have done another AI at the morning using defrozen imported Mura semen. On day 23rd, we have done the embryo flushing. That is at the 5th day of the embryos. Before embryo flushing, we have done the ultrasound scanning of ovaries to confirm the superovulation. So using the ultrasound scanning, we have scanned the corpora lutea there. Then at the embryo flushing, we used posterior epidural analgesia with lignocaine. Then we used 16 FR silicone flushing catheter, commercial flushing medium, white tubing system, and mini flush filter. So in this process, we have practiced retrograde flushing technique, as you can see in these pictures. Immediately after flushing, embryos were searched using the embryo-rich fluid remaining in the mini filter under the embryo searching microscope. Those embryos were washed 2 times using the embryo flushing medium before put into the embryo holding medium. While keeping in the embryo holding medium, those embryos were evaluated under the guidelines of FAO and International Embryo Technology Society. Under that, we have classified those embryos into 4 categories as excellent, good, fair, and poor by considering the development and defects of those embryos. Then part of excellent and good embryos were used for the transfer into the estrus synchronized animals as fresh embryos, while using the remaining embryos for the freezing process under the vitrification technology. At the transfer, we have loaded embryos into the 0.25 mini straws with embryo holding medium. Then embryo rich mini straws were loaded into the embryo transfer guns. Then embryos were transferred to the distal 1/3 of ipsilateral horn of corpus luteum in estrus synchronized recipient animals. At the embryo freezing, at first embryos were transferred into the embryo freezing medium. Then those embryos were loaded into the 0.25 ml mini straws with the embryo freezing medium. Then after sealing of those straws, those were plunged into the liquid nitrogen. These are the right embryo storage we have used there. When you look at the results, we could count 7 corpora lutea in animal number 1 and 4 corpora lutea in animal number 2 under the ultrasound scanning technology. As you can see in this picture, we can see lacunae of 2 corpora lutea very clearly with the hypoechoic background. Not only that, we could collect 7 embryos in animal number 1, 4 excellent, 3 good embryos. In animal number 2, we could collect 3 embryos. Those embryos belongs to the good embryo category. All embryos belongs to the morula stages. Then finally, we could collect 4 excellent grade morula and 6 good grade morula. So these are the embryos we have collected in our study. Then all 4 excellent embryos were used to transfer into the estrus synchronized recipient animals directly. Then out of the 6 good embryos, 2 were used to transfer into the estrus synchronized animals as fresh embryos. Then the remaining 4 embryos were used to freezing process right under the vitrification technology. However, we have done this study few weeks ago, so it is too early to do the pregnancy diagnosis in this stage. In conclusion, multiple ovulation and embryo transfer technology would be an important biotechnological tool to expedite the expansion of buffalo population while providing genetically superior buffalo calves to the farmers in Sri Lanka. Further studies are needed to optimize the technique under the local condition. This is our team, and thank you very much for your kind attention.